Alright, welcome to a drone AI kind of devlog. So, for the past week I've been working on some drone enemies, and I decided to share my progress here. So, originally I was looking for a drone controller. Um, I found a bunch on the asset store and figured it'd be much easier if I just used an asset, and came across this FPV drone controller. I wanted to make the enemies as realistic as possible using like physics for movement and everything, rather than it being just a transform value that moves around. I wanted it to be something that like actually flied, right? So I found this one asset. I'll leave a link to it down below if you're curious. Which is essentially meant for FPV drones, so you can control it and fly around in it like you would an actual FPV uh, drone. And this is all cool. Um, and it actually comes with all these settings, everything you can change here. But the cool part is for movement. So you can see there, takes in keyboard movement on the side. But there's also custom movement that you can add. So I took this and figured I could just make an AI that follows and uses that input to move the drone around using physics and forces and all that. So took that, went ahead and developed a little bit of a solution for it. So at first here, I wanted the drone to wander around. So kind of picking various destinations, going to that destination was a big part of the process here. So you can see this little drone flying around here and finding the target. But before we even got there, let me just move this guy a little bit further away from the enemy so he doesn't instantly just detect it here. Just go over there. Perfect. So essentially to start, this drone will wander. It'll start searching for enemies. So you can see, well, it's already found aggro again, but it's wandering. You can see the movement here. This is all done with the script, so you can see, boom. Still got to play with rotation a little bit. You can see this kind of jittery movement right here. It's a little bit unstable, and then it kind of flashes itself out. So still got to play around with rotation, but for the most part, the drone AI is actually pretty well done. As you can see here, it's attacking this capsule object, which is essentially the player, right? But you can see here, it's the drone, using the drone movement script from the FPV, added on with a custom script here that I'll go through in a moment, that does the wandering, kind of chasing, attacking side of things and movement. But the other part I had to do was pathfinding. For that I used A-star pathfinding. Made it 10 times easier to do any of the obstacle avoiding and all that. So you can see here is the A-star kind of defining areas. So just got a simple layer grid graph here. And essentially what the drone does is it calculates a path to the area on the ground, and then just uses the Y value of the drone currently, or the Y value of the target's position to follow along that path. So I still have to see how it works with kind of in-air objects and obstacle avoiding avoiding in the air, but for the most part it works relatively well on the ground here. But as you can see as well, it dynamically makes the path when this guy moves, so it updates there, takes the corner, boom. It also, let's say this guy were to go, see, it follows the rotation of the object there, backs up as well, when the player gets too close. But let's say this guy were to just phase through a wall there. Boom. Finds the new destination. Goes, finds the new destination again. It also has a bit of a wall check, so sometimes the player can be in the kind of no-go zone, right, for pathfinding. It'll be attacking them. Let's say for some reason, boom, they phase through. You see that yellow line there? Sorry if I was stuttering. Basically detects that there's a wall and it can't go through that wall to attack it, so it has to go all the way around, and then it creates a path to go around that wall. Also, velocity to the actual like target position is determined by an equation here. So basically, it'll be going faster the further away it is, slower, closer it is. You can see as it gets close, it stops there. There's still a couple of things I got to tweak. That's the kind of 360 thing. It's just distances and all that. But you can see chasing the target here. And when you take all the gizmos off, it's a lot easier to see. Let's say let's go all the way out there. You can go into game view here and watch it go. And go all the way to the target. And boom, there it is. Got too close, so it backed up a little bit there, and now it's attacking it. Going over wandering a bit more. Let's just move this guy even further away, change the rotation so it doesn't detect the enemy. And enemy detection, to see where an enemy is, it's essentially just a big sphere cast that finds where an enemy is. So this guy will randomly generate waypoints. I'll put the gizmos back on there, but you can see the red line is kind of where it wants to go roughly, and then you see the line at the bottom is the path that it will go to avoid any obstacles or anything like that. And then it just found the capsule over there, so it's gonna traverse all the way. Instead of walking into the wall, it goes all the way around the wall, just like that, and finds the enemy. Perfect, so let's go through the code here a little bit. It's really simple. It's not a state machine setup for the enemy. It's just enums and if statements essentially. Here, I'll just open this up and we'll see it all here in a moment. Alright, so here we are in the script here. You see a couple of things. It has reference to the drone movement script from the FPV drone asset. Has a current target right here, transform that it gets and sets. Has references to a bunch of different components. Also the seeker from the pathfinding, the A-star pathfinding, which is used for calculating the path, drone movement for moving it around, and then a bunch of other stuff for just moving the drone around. So initially, it'll just cache a bunch of components here and then start wandering. So every time we set the state, we go into this little guy right here, which essentially stops any coroutines if they're running. That just avoids a bunch of messy stuff that could go on. Also set movement coroutine to null. We do movement in actually a coroutine because of the paths, and I'll show that in a moment, but it's much simpler to just do it in a coroutine and have it kind of like threaded instead of pausing the whole game kind of thing, or doing it in a bunch of messy bools or whatnot. Then we just have a switch here, which is basically if the state is one of these guys, it'll start coroutines based on that. So let's say we're wandering. We're gonna check for some targets. So this is just a simple while loop. We grab check for aggro here. So this is the sphere cast I was talking about earlier. It's essentially a cone cast. There's a GitHub page for the guy who basically did all this code. I'll leave that down below. as well. But all it does is it does a sphere cast, see if it's within the angle, and makes it like a cone, essentially, instead of a sphere. It's a lot easier to just use this rather than doing a sphere cast and or just like a bunch of ray casts, right? So does a cone cast here, and then if it's within the angle of the cone that we set, it adds it to the list, returns the hits, and then for every one of those hits, if it's the player right here, we're just doing a compare tag to see if it's the player, which is relatively performant, and then we return the player essentially. So that's if we find a player inside this. So if we find a player, then we set the target to the player and then we chase after it. If we don't find a player, what we want to do is we want to do a bit of wandering. So this is relatively it just sets the drone's movement to 0 to stop it from moving around. Finds a random destination, so you can see all this stuff here. All it does is takes the transform position and looks ahead of it by stopping distance, which in this case would be 1, and then makes a new destination by quite literally just doing a random unit inside the sphere, and then multiplying that by wander radius, which is whatever we want to set to. I think it's at 45 right now in game, but we make a random destination, then we do a raycast to see if this random destination is actually a destination that we can physically go to. So we take the vector values, we add 100 to the y, and then we cast it down. So essentially we're casting from up in the air to see if there's a floor to go down to. And then if we hit something like ground, and the angle is within 45 degrees, and we set the desired destination, and then we draw a little line. That's just for debug. I can actually get rid of that. But we set the desired destination. If we find a random destination that works, that's actually on the ground. If we don't, we just return null, and it'll find another destination after an interval of 5 seconds right here. So if we get that destination back from find random destination, or we still have a destination in progress kind of thing, we'll start up the movement coroutine, and we will use the desired destination, that value that we just generated from the find random destination, to start that coroutine. So this is all the kind of juice for the drone movement. Still a bunch of stuff that I could improve on, and I know that for sure. But we'll go through it anyways here. Path. So first off, what it does is it finds a path to follow. So if there's no path, this is a cache variable because we reference it inside and stuff down below. We get the seeker component from the A-star pathfinding to make a new path. And that's just from the drone's current position to the whatever desired point it gets from the whoever called it, or whatever called it. Then once that path is complete, we go to this guy, which all it does is sets path to be there. But great thing about coroutines, you can do stuff like this right here, which all it does is creates a coroutine within the seeker game object. That's just wait for path that they nicely added for people like us who want to wait till the path is done in an object before doing anything else. So basically it'll tell the seeker, hey, queue me up a path, this will wait till the A-star pathfinding seeker finds a path. This sets the path count for 0. I'll go over that down below. Then after this is called, we should get our path back after this line right here. So at where those 3 slashes are, should see our path around here, because that'll be returned from onPath complete once this is done. If there's an error, just tell it to stop doing stuff, go back, find another destination. If there isn't, then we go into another while loop. So this is my kind of simple solution for traversing the path with the drone. So essentially the path it returns is a list of vector 3s. So all I'm doing here is with a count going through and setting the desired destination of the drone to these individual points. Then if the distance between the drone and the point is within a certain threshold, switching to the next point. There's definitely better ways to do this. However, I found this to be just the simplest, easiest, and relatively quick as well. Vector 3 distance calls aren't that crazy, and it's still relatively accurate as well at finding and going to the next path. But yeah, if you know a better way to do this, or have any ideas, just let me know down below. I'd love to hear it as well. Just sets backward to 0 and backing up to false. We have a backing up method that's called usually when chasing. If the drone gets too close, that just literally just sets backward to 1 for like a frame or 2, and that usually does it. Now for the rotation logic, this is something that I need to tweak a bit, but it works relatively well now. So what this does is it gets the direction of the drone and the desired point or whatever, creates a look rotation for it, finds the rotation kind of difference right here, and then what we do is, because the inputs for the drone are a value between 0 and 1, just like inputs kind of thing, we get the value of the difference for the rotation here. Is if it's greater than 180, then set it to -1. If it's less than that, set it to 1. So very simple movement here. And then we calculate the speed of the rotation by the angle difference. So we take the absolute value of the rotation difference multiplied by, or not multiplied, sorry, subtracted from 180 degrees. That gets the difference in angle. And then we just clamp the angle difference by time delta time between 0 and 1, because we don't want it to go less or more than those values. And we tell the drone movement script to rotate it. It's as simple as that. For going forward, we do a little bit of an equation here. We do distance divided by velocity times time delta time. And then we divide all that by movement forward speed to get the kind of averaged speed that it needs to go. And then set the custom speed forward with mathf clamp, because we don't want it to go over those values, otherwise it'll start doing some weird stuff. And that's all it is for forward. And the great part about this is we're doing rotation before we're doing forward, so that way the drone should always be relatively looking towards the desired point. That way when it's looking towards the point, all we have to do is send a forward speed, and it'll go straight to that point. Now we also have a Y movement as well. So what we do is we get the difference between the desired and the drone's position, get the absolute value of that, because it could be negative. And then if it's greater than y margin of error, we do have a little bit of a margin of error here. So as long as it's within this margin, we will move it up and down based on just a simple lerp. So it doesn't get too complex, and yeah, it's relatively simple and it works pretty well. The rotation logic still needs a little bit of work, some tweaking. Same with the path finding. It could be a bit more optimized. I'll show you down below as to why. And this is what changes over to the next point in the path count kind of thing. So if path count is basically at the end of its path, we just break out of the coroutine here. But if it's an enemy that is following, and this is a part that I'd also like suggestions on, because this I need to optimize a bit and figure out a better way to do this. But as of right now, what I'm doing is if it's an enemy that we're chasing and the path count, so let's say it's with like halfway through the path it's currently on, it'll break out of this loop here and actually just get called one more time. So this is getting called by chasing essentially, which I can show you for reference up here. So in chasing, basically it's calling the coroutine every update. If it's not currently moving at all. So all this will do is essentially call it one more time, make a new path towards the enemy. Let's say if it moved, right? So once the drone has reached halfway through the path that is currently taking to follow the enemy, or the player, sorry, it'll just create a new path. That way it goes to the correct position because the player can move, right? So if there's a better way to do that based on, you could do, let's say, even if you could cache the initial current target position or desired position here, like you could cache it, so like cached equals desired point, right? And then you could every update kind of see if the current target position, you know, is different than desired point. So you could do dot does not equal, usually not the best thing for vectors, but you could do that, and that could work as well. Sorry about the dog in the background there. But I found this to work relatively well. Yeah, that's essentially all the script there. You can copy this if you'd like. But yeah, this is what I found to be relatively good, and proud of the progress here. So yeah, this is my solution to a drone AI enemy within Unity. You can see it wandering here, and I hope you enjoyed. Hope I wasn't rambling on too much there. This is a bit of a longer video, and one of the only videos where I'm explaining the code. And there's a ton I could improve on, I'm sure of it. But yeah, let me know your thoughts down below. And thanks for watching. I'll just leave a little bit of video footage of the drone wandering around for a bit.